Okay, hello. The following presentation investigates motion on a 15-degree ski slope using scientific principles with Logger Pro. We will establish the speed of an object after 10 seconds moving along an incline. So we intend to calculate the velocity of a moving object on a 15-degree slope at the 10-second mark while eliminating both air resistance and friction effects from our calculations. First, we need to decompose the forces into their parts before applying Newton's second law. The downslope movement of objects creates a gravitational reaction, which points downwards towards the ground. The perpendicular force acting on the slope originates from surface contact. The parallel force to the incline from gravity serves as the accelerating force, which can be expressed through mg sine 0. The acceleration can be determined using this information. Applying Newton's second law along the slope, we find that acceleration is given by g sine 0. Plugging in g equals 9.8 meters per second squared and 0 equals 15 degrees. We calculate the acceleration. Using the kinematic equation, v equals v0 plus at, and knowing that the object starts from rest, we multiply acceleration by time to get the final velocity. The result is approximately 25.4 meters per second after 10 seconds. The illustration in this slide displays the acceleration versus time data from Logger Pro. Because acceleration does not change from 2.4 meters per second squared, the graph becomes flat. The graph validates that Newton's second law controls incline motion by demonstrating gravity as the single element that drives acceleration. The incline angle establishes the effective acceleration value, which in this trial stays at 2.54 meters per second squared. The exact visualization of this concept emerges through Logger Pro's accurate acceleration graph presentation. The conducted experiment produced the velocity time graph visible on this slide, which Logger Pro generated. The graph demonstrates straight line motion with positive slope because the skier begins without velocity before achieving constant acceleration. The slope value indicates the acceleration level of 2.54 meters per second squared. The equation, velocity equals 2.54 t, enables velocity estimation for any time frame, while the skier reaches 25.4 meters per second velocity during 10 seconds. Our calculations match exactly with these findings, which demonstrates that objects moving down slopes obey familiar kinematic equation. Our analysis applied physical principles to slope motion while revealing that 25.4 meters per second will become the final velocity after 10 seconds of motion. The data verification process enabled by Logger Pro includes the creation of motion graphs which provide confirmation of results. Physics professionals need to comprehend these concepts so they can apply them to skiing activities in engineering fields and transportation systems effectively. The reference presented in this work consists of Pearson and the Logger Pro user guide and the 4 YouTube videos. I appreciate you listening, and I'm ready for any questions. Thank you.